systems algebraically. So you guys have already done this. We're looking at the substitution and the elimination methods. 3, 2, day 1. It's in your packet. So for the warm-up, we're going to talk about is when we solve these systems algebraically, you have to solve by substituting. And a part of substituting is being able to know what opposites are, what additive inverses are. So what we want to talk about are additive inverses, which are also a fancy way of saying the opposite. And then we want to talk about substituting. So the additive inverse of 4 is negative 4. The additive inverse of negative x is positive x. The additive inverse of 5x is negative 5x. So that when you add them together, they equal 0. That's what additive inverses are. So opposite of 8y, negative 8y. And the reason we need additive inverses in this unit is for the elimination method. Because in the elimination method, you want to find additive inverses so you can eliminate a variable. Today, our focus is going to be on the substitution method. So that's why as part of our warm-up, we substitute. So what we're doing is substituting 2y minus 1 in for x. So everywhere you have an x, you're going to replace it with 2y minus 1. So everywhere you have an x, you're going to replace it with 2y minus 1.
Wait, are we solving this all the way through?
Yeah. So you get 2y minus 1 plus 2y equals 3. 2y plus 2y is 4y minus 1 equals 3. Add 1 to the other side. 4y equals 4. Therefore, y equals 1. So we just have to solve for y in the warm-up. In our notes, we have to solve for x and y because we're looking for the solution, which is the ordered pair. Okay, and number 6, you have y minus 2 times 2y minus 1 equals 8. In that middle problem, we have to distribute the negative 2 inside the parentheses. So you get y minus a minus, so you have y minus 4y, because the negative 2 distributes in, and then negative times a negative gives a positive 2 equals 8. You get negative 3y, and then subtracting over the 2 equals 6, or y equals 6 divided by negative 3, or y equals negative 2. In 7, we have 2y plus 3 times 2y minus 1 equals negative 5. Distribute and combine like terms. And you get y equals negative 1/4. You'll notice, especially in this topic, I have a tendency to box in or circle my answers. There's a lot of not hard algebra, but algebra in general, so it's very helpful to box in your answers when checking. Okay. Number 1, we have x plus 3y equals 12 and negative 2x plus 4y equals 9. When we are looking at these problems, if it tells you to use the substitution method, so if it says use the substitution method, you have to solve for a variable and plug in and substitute. So if you are substituting, you want to pick the variable that has a coefficient of 1. So in this case, that's x. So if I'm looking at those two equations and all four variables, I want to solve for x because it'll involve the least amount of work. So we get x equals 12 minus 3y. And then what we're going to do is take that x equals and replace x in the next line or the equation below it. So you solve for a variable in one, and then you plug that in to the other. So you solve for a variable in one equation, and you plug it into the other. So we get negative 2, replacing the x, you get 12 minus 3y plus 4y equals 9. And what that does is create your equation in terms of one variable, allowing us to solve for that variable. You get negative 24. Negative times a negative is a positive 6y plus 4y equals 9. 4 plus 6 is 10. So you get negative 24 plus 10y equals 9. Add your 24 to the other side. You get 10y equals 23. So you get y equals 23 tenths, or
Wait, 33.
Sorry, 33. Just making sure you're awake. Yeah. All right, 3.3 or 33 tenths. Then what you do is you take that answer and you plug this y value in here and solve for x. Because in order to solve the system, just like when you graphed, you had x comma y, we have to plug x or y in to get the other variable. So you get x equals 12 minus 3 times 3.3, or 12 minus 9.9. My board is not happy right now. I changed colors. 2.1. Good. So this is a problem where, like, you see we have these decimals. This one wouldn't be very nice to graph because they're not going to meet at a coordinate corner. So that's why it's important to have methods for solving by hand and methods for solving by graphing. Number 2. This time, it doesn't matter which variable we solve for. We're going to pick the bottom equation because the x and the y's have coefficients of 1. So you could choose which variable you solve for. Let's say I solve for y. Then I get y equals negative 12 minus x. So I'm going to take the negative 12 minus x and replace the y. So you get 2x minus 3 negative 12 minus x equals 6. 2x plus a negative times a negative gives a positive 36 plus a positive 3x equals 6. Combine like terms on the left, so you get 5x. Subtract 30 to the right, so you get negative 30, or x equals negative 6. Plugging that negative 6 back in, you get y equals negative 12 minus a minus 6. So it's like a positive So negative 12 plus 6 gives negative 6. In number 3, I would solve for y. Otherwise, you're going to have a fraction. So in 3, I would solve for y. So I have no fractions. So I just add my y to the other side so that I had 3x equals y. Replacing y, yeah.
Does the y have to be positive? Or can it be negative?
It has to be positive. So then you get 4x plus 3 times 3x equals 26. You get 4x plus 9x equals 26. 4 and 9 gives 13x equals 26. Divide both sides by 13, and x equals 2. And then plug 2 back in for x, and you get y equals 3 times 2, or y equals 6. You could check any of these by plugging your x and y values in to either equation, and if you plug them in, it should be true. Meaning, like, if I plug 2 and 6 in, 3 times 2 is 6, 6 minus 6 is 0. Like, if you plug in that x and y, it would be true. You know, I know how much we love word problems. Unfortunately, chapter 3, the remainder of it, is a lot of word problems. So we're going to do a little bit of word problems every day to really help us get comfortable. Chapter 3, section 4 is linear programming. It is all word problems. So I know how happy that makes us. We have Rinaldi's Pizza. They offer a deal where a soda and 2 slices of pizza cost $10.25, or a soda and 4 slices of pizza cost $18.75. Find the cost of a soda and a slice of pizza using our systems of equations. So we're going to say that S represents soda and P represents the pizza slice. So a soda, so 1S, plus 2 slices of pizza is $10.25. Or 1 soda plus 4 slices of pizza is $18.75. So if I'm picking a variable to plug in, I want to pick a variable that has a coefficient of 1. So I could pick either the top or bottom equation to solve for soda. It does not matter which one you pick. It's going to work out the same either way. So if we pick the bottom one, 1 soda would be $18.75 minus 4 slices of pizza. Plugging this in for soda in my top equation, you get $18.75 minus 4p plus 2p equals $10.25. Combining like terms, you get negative 2p. Subtracting, what the heck? 1875, 1025 minus 1875. It seems weird that you're going to have it equal to a negative, but we have the negative 2p. So like when you divide by your -2, they're going to cancel out. So 1875 and 1025 is -8.5. Divide both sides by -2. And a slice of pizza costs $4.25. And then you could find the cost of a soda by plugging that back in. So 1 soda plus 2 slices of pizza equals $10.25. Subtract $8.50 from your $10.25. And a soda, if it lets me write it, is equal to what? Got it.
175.
Yep. And again, we're talking about money, so we put our dollar signs. You can buy CDs. Well, you could. I guess you still can, but you guys like don't know what CDs are. Just use Apple Music.
I used to watch movies.
You watch movies on CD.
Those are DVDs. Not CDs.
Wait, what does CD stand for?
Compact disc.
There goes
Compact drive. What does DVD stand for?
Disc. Compact disc.
What does DVD stand for?
Digital video disc.
So it's basically the same thing.
I don't know though. They're different. All right. I don't know what can of worms I opened back there, but you can buy CDs at a local store for $15.49 each. You can buy them online for $13.99 each. However, you have a $6 shipping fee. Find the number of CDs that you can buy for the same amount at the 2 stores. So basically, we want to know, when is the cost the same? So cost is $15.49 per disc in store. The cost is $13.99 per disc plus $6 shipping online. So if we want to know when the cost is the same, since they're already both solved for C, you're really just replacing one with the other. So you get 15.49 equals 13.99 plus 6. So you combine your like terms. So we'll subtract $13.99 from $15.49. Like something. Is it 150 nicely? I feel like I made it nice and then I equals 6. Yeah, so then you get 3 halves. 1, 2, 6 times 2, it's like 12. So divide both sides by 1.5. So divided by 3 halves, divided by 3 halves, is times 2/3. So 4. He said yeah, so like, you made me feel like it was wrong. So you can buy 4 CDs in store or 4 CDs online, and the cost would be the same. Which one would you want to do if you bought 2 CDs?
The top. Yeah, the
For
top.
2 CDs, you do this.
No.
Yes. You do the 15.49
No.
for 2. Yes, you would.
Let me do it.
Yes, you would, Chip. It's common sense.
You want the top one.
Because the
Yeah,
top
it's the
one,
top one.
yeah,
It's
the
the
top
top
one
one.
is
It's like
much
34
more-
versus 31. Yeah. Okay. Your homework's the next page
Yeah, it's the
of your
top one.
packet.
Yeah.